Hi there, and welcome to this lesson on Pure Mathematics 4. And in this lesson, we're on Chapter 4, 4.1, and how you use the binomial expansion to expand expressions of the form 1 plus x to the n, where n is negative or a fraction. Now, back in Pure Mathematics 2, you'll have met the binomial expansion before, where rather than having 1 plus x, you normally have something like a plus b to the power of n, and we only considered values of n where n was a positive integer. We'll be expanding it in this lesson to where n is a negative number or where n is a fraction. But first of all, we'll just quickly go back over some of the essential stuff from Pure Mathematics 2. One thing that we use a lot when we're doing work on the binomial expansion is NCR. And you may see NCR written in this notation, or you may see it written in vertical brackets. We have n above r. Both things mean exactly the same thing. On your calculator, there should be a button which has something very similar to that NCR on it. And the formula for finding NCR is n factorial over r factorial times by n minus r factorial. There are a lot of different ways to calculate NCR. The first is the one we just said. So for example, if you were using the formula to work out the value of 6c3, then you'd have 6 factorial, n is 6, times by 3 factorial, r is 3, times by 6 minus 3 factorial. Now pop all of that into the calculator and you'll get 20 for the answer. What exactly is 6c3? What does it mean? I think the easiest way to understand it is if you had, say, a class with 6 students in it, and you wanted to choose 3 of those students. This is saying that there are 20 different ways that you could choose 3 students out of a total of 6. That's what it means. Now, as we said, there should be on your calculator, hopefully, an NCR button, and you should be familiar with that. So normally you would press the number 6 first, then you press the NCR button, then you press 3, then equals, and your calculator should give you 20 for the answer. Pascal's triangle is also well worth understanding in this context. And you can calculate 6 choose 3 from Pascal's triangle. Pascal's triangle starts off like that, starting with 1, then 1, 1, then 1, 2, 1. And each number is the sum of the 2 above it. So 3 is 1 plus 2. 10 down here is 4 plus 6. That top row is really the 0th row. The second row is the first row, then the second row, then the third row, the fourth row, the fifth row, the 6th row. And we're on the 6th row. We want to know what 6 choose 3 is. So you'll notice that the first value on that row is 6 choose 0, then 6 choose 1, 6 choose 2, 6 choose 3, and so on and so on. And 6 choose 3, that'll be the sum of the 2 numbers above it, which is 10 plus 10. So 6 choose 3 is equal to 20, as we found using the formula and from our calculator. Now, the main way that this is very useful is expanding something of this form, where you've got 2 things in brackets to some integer power, positive integer power. So something like x plus y to the power of 6. Now, to work that out, you've got 6 brackets that you would need to multiply together. Now, you could do that, multiplying all the brackets out, collecting together all the terms, but it would take a very long time. Using the binomial expansion, essentially what we're doing is we're saying that the terms follow a pattern. So if we chose x from each of those 6 brackets when we were multiplying them out, x times x times x times x times x, we get x to the 6th. If we chose 5 x's from 5 of the brackets and a y from the other bracket, then we'll get terms in x to the 5y. If we chose x from 4 of the brackets and y from the other 2, we'll get terms in x to the 4y squared. If we chose x from 3 of the brackets and y from 3 of the brackets, then we'll get terms in x cubed, y cubed. Now the question is, how many of each of those terms do we get? Well, the answer is the 6th row in Pascal's triangle. So if I fill in the rest of the numbers for the 6th row, I'd get 1, 6, 15, 20, 15, 6, 1. And those numbers are the coefficients of these terms. So x plus y to the 6 will equal 1x to the 6 plus 6x to the 5 times y, and so on and so on. Now understand why what we're doing there is n choose r. So for example, these 15x to the 4y squareds, what we were asking was, if you had 6 brackets multiplied together, and I had to choose x 4 times, how many ways are there of doing that? Well, there are 15 ways of doing that. So there are 15 ways of choosing x from 4 of the brackets and y from the other 2. Note the symmetry. What we're asking there is exactly the same as this term here, where we've got 15x squared y to the 4, where essentially what we're saying is we've chosen y from 4 of the brackets and x from 2 of the brackets. And again, there are 15 ways of doing that. It's exactly the same question as we were asking here, just swapping the x's and y's over. So that's why you get symmetry with these terms. Now, there is a final way of calculating NCR, which we didn't learn in Pure Mathematics 2, which can be very helpful. So NCR, that's the normal formula, n factorial over r factorial times by n minus r factorial. I'm going to write these out a little bit more fully. So n factorial means n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1 at the end. I've included a few middle terms because they'll be significant in a moment. R factorial I've left as r factorial because I'm not actually going to do anything with that. But n minus r factorial I've chosen to write down as n minus r times by 1 less than that, times by 1 less than that, till we get down to 3 times 2 times 1. And the reason for choosing these terms on the top and all of those terms on the bottom is because these ones here and these ones here are exactly the same as each other. And we're just multiplying things together, which means we can cancel all of these terms from the top, and we can cancel all of these terms from the bottom. And by doing that, we get another form of the equation for NCR, which is n times n minus 1 times n minus 2. You keep all the way until you get to n minus r plus 1, and then you divide by r factorial. What's the point in that? Why have a new way of calculating NCR? Well, the helpful thing about this form is that it does not include n factorial. It still includes r factorial, but it doesn't include n factorial. And n is the power of the bracket. And what that means is n can now be a negative number or a fraction. It couldn't be before because n factorial isn't defined if n is negative or a fraction. But we've managed to sidestep having to use n factorial at all, just by saying we'll start off with whatever n is, then take away 1, then take away another 1, till we get down to this term, and then divide by r factorial. Okay, the binomial expansion. First of all, a reminder of what we've done before. So when n is a natural number, that means the power here is a positive integer. We use this form of the binomial expansion, and this is the form that you should have met before. But if n, the power, is a fraction or a negative number, then we use the following form of the binomial expansion, and we obtain an infinite series where we're using a equals 1. So this term here in the brackets, a becomes 1. B equals x. Instead of writing b, we write x. And NCR, we calculate by this new method. All of that gives us a new formula, which is that 1 plus x to the power of n is equal to 1 plus nx times by n times n minus 1 over 2 factorial times x squared plus n times n minus 1 times n minus 2 over 3 factorial times x cubed. And each term, we just add on another bracket for n and take away another integer from it. The expansion isn't always valid. It's only valid when the modulus of x is less than 1. And you may see this written down in 2 ways. So they may write the modulus of x is less than 1. Most people find it slightly easier to understand if you write it like this. So where x lies between minus 1 and plus 1. Both of those things mean exactly the same thing. And it doesn't matter which you write. Where n is any real number. Okay, let's do an example. Find the first 4 terms in the binomial expansion of 1 over 1 plus x. Now 1 over 1 plus x, you'd need to rewrite. That's equal to 1 plus x, all to the power of minus 1. Now it's in this form. So we substitute n equals minus 1 into the formula. The 1 plus x is identical, so we don't need to worry about that at all. All we have to do is change n into minus 1 in the formula. Okay, I'll let you have a go at doing that yourself. So see if you can finish this off, pause the video, and come back to me when you're ready. Okay, no tricks or catches on this question. If we substitute n equals minus 1 into the formula, then we get 1 plus minus 1 times x. N is minus 1, then we've got to take away another 1, so minus 1 take away 1, then 1, minus 1 take away another 1, and then minus 1 take away 2, and so on and so on. Tidying those up will give us that, and multiplying out all these brackets on the top will give us that, and finally simplifying those fractions will give us 1 minus x plus x squared minus x cubed, and so on and so on. And those are the first 4 terms. Okay, example 2. Find the first 4 terms in the binomial expansion of 1 plus x to the power of half, and state the range of values of x for which the series is valid. Now again, no tricks, no catches in this. All we're doing is substituting n equals a half into the formula. So 1 plus x is identical inside the brackets. We don't need to worry about that for the moment. We're just substituting n is a half. Have a go at doing that, pause the video, come back to me when you're ready. Okay, let's have a look. So all I've done is substitute n equals a half into the formula. It's these brackets you need to walk carefully on. So we'll have a half minus 1 is minus a half. Take away another 1 will take me down to minus 3 over 2 in this last bracket over here. Then it's just tidying things up. So multiplying out those brackets would give me this, and then simplifying these fractions would give me 1 plus a half x minus 1/8 x squared plus 1/16 x cubed, and so on. Those are the first 4 terms. Now we were also asked to state the range of values of x for which the series is valid. Now what you need to look at is this term here, but this term is just x. We've got 1 plus x. So the expansion is valid if the modulus of x is less than 1. Example 3. Find the first 4 terms in the binomial expansion of 1 over 1 minus 3x to the third, and state the range of values of x for which the series is valid. The first step has been done for you here. If you've got 1 over 1 minus 3x to the third, writing it in exactly the same form as the formula, that'll give us 1 minus 3x to the power of minus a third. Now this question is slightly more difficult. This is the first question where instead of having x in the brackets, in the question, we've got minus 3x. That means 2 things are going to have to be substituted into the formula. So looking at the power, n is minus a third. So we'll substitute that in the normal way. But x has become minus 3x, which means instead of writing x in the formula, we'll be writing minus 3x in brackets in the formula. Okay, I'll let you have a go at seeing if you can make sense of what's going on there. So pause the video, have a go at doing this yourself, and then come back to me when you're ready. Okay, let's have a look. So as we said, it's a little bit more tricky because 2 things are having to go into the formula now. So instead of n, I've got minus a third, and I take away 1 from that in the normal way, and then take away another 1. Instead of x, I've got minus 3x, because x in the formula has changed to minus 3x. So x squared becomes minus 3x all squared. X cubed becomes minus 3x all cubed. Do use brackets, otherwise it's very easy to make a slip on these. That's the important bit. From here on, it is really just tidying things up. So first of all, I've squared the 3 here to get 9. I've multiplied these brackets together to get 4 over 9. Here, these 3 brackets multiply together to give me that. And minus 3 cubed is minus 27. And I've taken the x squared, and the x cubed outside of the brackets. Continuing to tidy that up, the answer is 1 plus x plus 2x squared plus 14 over 3 x cubed plus continuing onwards. But those are the first 4 terms. Now, we were also asked to state the range of values of x for which the series is valid. For the first time, this isn't completely straightforward. So the series is valid if the modulus of x is less than 1. But this x here is referring to whatever term you have here in the brackets. Now, we've got minus 3x in the brackets. So rather than saying that the modulus of x has to be less than 1, x has changed to minus 3x, as we said here. That means the expansion is valid if the modulus of minus 3x is less than 1. Now, modulus changes a minus to a plus, so it means exactly the same thing as if the modulus of 3x is less than 1. And then we can just divide by the 3. And that means that the modulus of x must be less than a third. Okay, example 4. Find the first 4 terms in the binomial expansion of 1 minus 2x to the power of minus a half. And then by substituting x equals 1/10, find an approximate value of x equals root 5. So approximate value of root 5. 2 parts to the question. The first part is identical to what we've been doing on the previous questions. So let's just worry about that for the moment. So looking at what we've got here, we're going to substitute in n equals minus a half, because that's the power. And looking in the brackets, instead of x, we've got minus 2x. So we're going to substitute x equals minus 2x into the formula. Same as the last question. Do that. Once you've done that and got the answer, just press forwards. Substitute in x equals 1/10 or 0.1 into your answer and keep simplifying things until you get to something like root 5 equals. And at that point, you'll have an approximate value for root 5. Okay, I'll let you have a go at seeing if you can make sense of that. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So it begins as normal. N is minus a half in this question, x is minus 2x. All we have to do is substitute those values into the formula. That will give us that. Again, I'll square these brackets first. So minus 2 squared is plus 4, minus 2 cubed is minus 8, and multiplying these brackets together gives me 3/4. Multiplying these 3 brackets together gives me that. And then it is just simplifying things. So putting that in the calculator, you should get 1 plus x. This all simplifies to 3 over 2x squared, and this all simplifies to 5 over 2x cubed. That's the first part of the question. Now, the question continues by saying, by substituting in x equals 1/10, find an approximate value for root 5. Now, if we put x equals 1/10 into the formula that we've just got, then if we're just going to look at the first 4 terms, so I've got rid of the extra terms here, instead of being equals to, it's now become approximately equals to, because I'm only looking at the first 4 terms, and I am neglecting all the higher power terms. Substituting in, x is 1/10, so 2x will be 2/10. And here I've written x is a 10th as a decimal, 0.1, x squared will be 0.1 squared, x cubed will be 0.1 cubed. 1 minus 2/10 is 4/5. So 4/5 to the minus a half equals this. Dealing with the minus here. So minus turns the fraction upside down. So 4/5 to the power of minus a half is exactly the same as 5 over 4 to the power of plus a half. And all of this I've just put into the calculator and got 1.1175 for the answer. Now, square rooting the 2 terms here. So root 5 I've just written as root 5, and the square root of 4 is 2. So root 5 divided by 2 is approximately equal to this. And it's only at this point that you can understand why they asked you this question, because all I have to do is move the 2 to the other side, and 2 times by 1.175 gives me 2.235, and that will be the approximate value for root 5. Now, if you want to see how accurate it is, all you have to do is put root 5 in your calculator, and you get 2.2360679. So it is surprisingly accurate. Example 5. Find the terms up to x squared in the binomial expansion of 2 plus 5x divided by 1 minus 3x squared, and state the values of x for which the series is valid. Now again, the first part of the question is just the same as normal. So we'll just think about this bottom part of the fraction. So 1 over 1 minus 3x squared, that is the same as 1 minus 3x to the power of minus 2. And we're then going to expand this in the normal way by saying n equals minus 2, because that's the power. And a bit like in a previous question, instead of having x, we've got minus 3x. So we'll be substituting x equals minus 3x into the formula. We'll get the answer for that in the normal way. But then once we've got the answer for that, then we'll need to multiply it by 2 plus 5x. So you'll have 2 plus 5x times by the answer you get for this. And all you need to collect are the terms up to x squared. So any higher power terms that you get than x squared, you can ignore those. Okay, I'll let you have a go at working through that yourself. So see if you can work your way through this question. Have a go, pause the video, come back to me when you're ready. Okay, let's have a look. So substituting minus 2 and x equals minus 3x into the formula gives me that. Squaring these and multiplying these brackets together, it simplifies to that. And then finally, just simplifying all of these coefficients gives me 1 minus 3x to the power of minus 2 is equal to 1 plus 6x plus 27x squared plus 108x cubed plus higher order terms. Now, I've got 2 plus 5x over 1 minus 3x squared in the question. That's what they were asking us to find the expansion of. Well, 2 plus 5x divided by 1 minus 3x squared is exactly the same thing as 2 plus 5x times by 1 minus 3x to the power of minus 2. Well, I've just found this second bracket using the binomial expansion. So I can substitute the first 4 terms into there, and that's all I need. In fact, it's more than I need, because I only need to find terms up to x squared in my final answer. And now I'm going to multiply these brackets together. So I'll do 2 times the 1, 2 times the 6x, 2 times the 27x squared. I don't need to do 2 times the 108x cubed, because that's a higher power than x squared. 5x times by the 1, 5x times by the 6x, and that's as far as I need to go. I don't need to do any more. 5x times by the 27x squared will give me a term in x cubed, but that's more than I need. So multiplying out the terms that we said will give you that, and then all I need to do is collect together the x terms and the x squared terms, and that will give me 2 plus 17x plus 84x squared plus higher order terms that I haven't worked out because I wasn't asked to work them out. The final thing we're asked to do on this question is state the values of x for which the series is valid. And this is the same as a question we had before. Instead of x, we've got minus 3x. So you say that the modulus of minus 3x has to be less than 1, which means that the modulus of 3x has to be less than 1, which means that x, or the modulus of x, has to be less than a third. Or if you prefer, you can write it like this. That's just saying that x has to be between minus a third and plus a third. Those mean the same thing. You can choose to write either down. Okay, example 6. Looks harder this, but it's not too bad. In the expansion of 1 plus ax to the power of a half, the coefficient of the x squared term is minus 2. Find the value of a. Okay, what you want to do is expand this in the normal way. It's the x squared term that you're going to be interested in. You want to see what the coefficient is, and then say that equals minus 2. Solve that little equation that you'll get, and you'll be able to find the value of a. I'll let you have a go at doing this yourself first. So pause the video, see if you can make sense of it, and come back to me when you're ready. Okay, let's have a look. So in this question, n is a half and x is ax. So we're going to have to put n equals a half in the formula and ax into the formula for x. That will give us that. It's the x squared term that we're interested in, so we can ignore everything else. The x squared term is this term here. A half times minus a half is minus a quarter. 2 factorial is 2. And ax all squared is a squared x squared. Multiplying this out means that the coefficient of the x squared term is minus 1/8 a squared. Well, we're told in the question that the coefficient of the x squared term is minus 2. That means that this coefficient here, minus 1/8 a squared, must equal minus 2. That means that a squared is equal to 16. That means that a could equal plus or minus 4. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 35 and have a go at exercise 4A. Thank you very much for listening, and cheerio.